Hello, welcome to Lab 3, MATL 3101. This is the lab where we take the tensile samples that we pulled last week, except we didn't pull them last week. We'll have to do that in the future. But we take those tensile samples and we cut, mount, polish, and photomicrograph, and etch and photomicrograph. So let's go through that one step at a time. Let me grab my sample. This is a tensile sample. You'll see more of that later. But it's threaded on both ends and the test region is in the middle. After we do our test, in which case the sample would normally be broken, we want to cut a sample of the test region and analyze that to get the microstructure. So this is the Lico abrasive cutoff saw. Take your sample, place it in the vise, which is on a linear bearing. Place the sample in the vise, push it with your hand and clamp it. It's very secure. Now, notice that the blade is positioned just to the left of the vise, which is what you want. And you also want to make sure that the lubricant nozzles are pointed at the cutting action, okay? So what we're going to do is check to see where we want to cut and make sure the nozzles are pointed in the right place. Then we release that and close the hood. Now, you turn on the machine right here and turn on the blade right here. When you turn on the blade, the lubricant also comes on. I'm going to turn that off so you can hear me, but with the saw running and the lubricant running and pointing at the blade at the cutting action, gently pull the blade down, make contact with the sample, and cut the sample. Do not press or pull hard. You do not want to do this quickly. Take 1 or 2 minutes, gentle, firm pressure, and you'll see sparks. That's okay. Hopefully your sample will not move. That's another reason you don't want to pull too hard. Just pull firmly and be patient. Allow a minute or two if you need to, whatever it takes to cut it. When it's cut, release the blade, come back over here, turn off the blade, and lift the hood. Well, I'm sorry, turn off the blade and the lubricant if necessary, and then lift the hood, retrieve your sample, and then reposition the remainder and cut off. You've got to cut off one piece to use for your sample. If you have to cut another one, just reposition the sample by loosening the vise, reclamping, and repeating the process. Okay? When you're done, retrieve your sample from the bottom of the stage. Again, make sure the lubricant is pointing at the blade cutting the sample. Make sure you don't pull too hard. That's pretty much it. Now, when you're done, remove all your materials, and you'll have to clean the saw. Take this hose that's on the back, open the valve, turn on the lubricant, and rinse off the stage and the bottom of the saw chamber. Turn off the lubricant. Close the valve, turn off the lubricant in either order, but make absolutely certain that you close this valve, otherwise the next guy will have a mess. So close that valve, take your paper towel, Wipe off the stage, the bottom of the chamber near the cutting area, and the glass inside the hood. And then you're done. The next step, take the sample that you cut, bring it over to the Struer's Level Press 3. This is what's called a hot mount. The hot mount will produce a metallographic sample similar to this one. It has a sample of the tensile bar already mounted in it. This is phenolic resin. So you place the sample that you just cut on the stage right here on top. Turn the machine on the side. You see the lights come on. These settings should be correct. If you'll notice, the force is set on 20 kilonewtons. The heating operation is on 7 minutes, and the cooling operation is on 3 minutes. That should be about right. The temperature is also should be 180, and nothing should change there. Once you place your sample on the stage, lower the stage right here. Down into the press. It takes about 10 seconds. Seems like more. Then you take your phenolic resin, which is called Durofast, or Durofast, green or black, doesn't matter. Put 2 small scoops, maybe 2.5, using the small scoop, 2 scoops inside this chamber. Be careful not to spill any on the outside here. Put it inside the press. Once you do that, take the cap, place the cap on the press, and then press down and tighten it up all the way till it's tight. Then, important, come back 1/4 turn. Okay? That puts the press in the right position. Press start. When you press start, the press will move into position, compress your sample and the phenolic resin, and it will begin the heating process under pressure. It will automatically complete the heating process and the cooling process. You should see cooling water come out in the sink, and then it'll be complete. When the cooling operation is complete, then the first thing you do is unscrew the cap, place it back in the holder, and raise your sample. Do not raise the sample before you release the cap. Too much pressure may cause damage to the machine. That's pretty much it. When the sample raises up, you'll have a sample that when the stage rises, you'll see a sample similar to this, except it won't be nice polished or roughly polished like this one. It'll be a little rougher, but essentially it'll look like this. Next thing you do, by the way, when you finish, just turn off the machine, wipe everything up, make sure the materials are back where they go, and that's it. Now, the next step is one in which you can get hurt if you're not careful. Now, by the way, for this lab, you're probably not going to use this abrasive saw. I think that will already be done for you. So you're probably going to start with the press that we just did. So in your case, the second step, but you need to know how to use that saw for future reference. The next step at this point is to use the rough polisher. The rough polisher has 2 platinums. This one is normally set to 120 grit paper. This one to 320 grit paper. This one is very rough. This one is more smooth. This is still called a rough polisher. Now, I said you could get hurt. When I turn this on, I want you to notice how much force on which this machine comes on, and how much force is utilized to operate this machine, how fast the platen is spinning, and you can either polish off the tips of your fingers, which, trust me from experience, is painful, or you could, if you're not careful, get your finger caught here, and that would be even more careful. I have no experience with that, and I hope I never do. For the rough polisher, you want to turn on the water, just like in your house. Get a nice little stream. You don't need much, just a tiny little stream. And turn on the machine here. By the way, this turns the machine off. On and off, that's all you got. And the water. So turn it on and listen. Okay, that's a lot of force. That's a lot of torque and a lot of potential to damage your fingers. But what you're going to do is start a rough polish. Take your sample, the side of interest first, down obviously. Try to hold the sample perfectly vertical, just a small amount of pressure, not a lot. Let the paper do the work. If you're not careful, you will end up with multiple facets on your sample, and that's hard to get back from. So just try to press evenly and try to get a rough polish to cover the entire sample. It should be nice and shiny, and that's all you're trying to achieve with this step. Turn off the platen, turn off the water. You can also use this platen with the finer paper, or you might get started with this one. That's your choice. You might could just experiment. Just understand, this one is a rougher polish than this one, but they're both rough polish. 120, 320. Same thing applies here, just be very careful. Now, for the next step, we have a manual polisher. We have two manual polishers, and these polishers, and by the way, what's happening here is that you're going from very rough polish to finer and finer polish until you end up with a very nice polish, hopefully, okay? So the next step here is to use the manual polisher. This one starts out at 320 and increasingly gets finer and finer, 400, 600, and 1000. They're both the same, okay? Make sure there's paper there in each one. You also have water here. Turn on the water with this one. Use the valve that's provided by the manufacturer. Turn on the water, just enough to get a little water going. You may even turn it off and then turn it back on here and there. What you don't want is to overflow on your shoes. Turn the water on with this valve. On this machine, this valve is broken, so you have to use the next valve behind it to accomplish the same thing, okay? That water is to help you with your polish. So what you do is take the sample surface that you just rough polished, and now you want to do a series of strokes on the 320 grit paper. Go in one direction rather than back and forth. Just go one, and generally on the order of 12 to 20 strokes will accomplish what you want. You can look at your sample and see that all the scratches are moving in the same direction. That tells you you're making progress, and you can move on to the next step. If you see scratches going in different directions, then keep looking. I don't know if you can see what I'm talking about, but hopefully you can see that all the scratches are in the same direction, and then you can go on to the next step. Turn your sample 90 degrees and go on to the next step. Turn on the water as you need to. Say 20 strokes. Now you turn your sample 90 degrees because you want to see if all the scratches are in the same direction this way. And that's a good trick to make sure that is the case. So just turn your sample 90 degrees as you go from one paper to the next, and that way you can use your sample to see your progress. Okay? Go on to 600, do the same thing. Rotate your sample 90 degrees. Again, 20 strokes or so in one direction, not back and forth, and you should end up with a pretty nice finish after 1000 grit. Okay? That is that'll take you to a 1000 grit finish, and you should see at this point a pretty nice shiny surface. Not a mirror surface, but a pretty nice surface. Fine scratches all in one direction. Okay? That's it. So the next step is what we call, I guess, a medium grade polish. There's varying levels of grinding and polish. We started with grinding, then rough polish, medium polish, and then I'll show you the fine polish. At this stage, this is the Lico VP 160 polishing table. We have 4 platens. Very similar to the other one, the first one we used. We have a little faucet here, and we have a couple of guards for your safety. Okay, so what you want to do is take your paper and start with 1000 grit. Start with 1000 grit and hold the paper in place, put the ring on, make sure the paper is nice and smooth, put the guard on, rotate the water into position, and then come around here, turn on the machine by pulling this knob. You'll see a light come on, and the platen should begin to turn. You can adjust the platen speed right here, RPM select, and you can adjust the water for the faucet right here. Now there are 2 water sources. There's the water that comes from the faucet, and there's a bowl wash underneath the platen. You can see it's called bowl wash and wheel wash. What you want is the wheel wash. Turn on the wheel wash. There we go. Now, you may find that the water is valved off right here. So, with your valves on here, your local valves off, turn this one on, just partially, and then let's try again. There we go. Now we have water. So again, you may have to turn on this valve first, make sure it's on before you turn on the wheel wash. Very similar to the previous operations, just hold your sample in place. There is a whole lot less risk of injury in this process, but you can still polish the tips of your fingers, and that is painful. Just avoid that. Gentle pressure. I like to rotate a little bit, rotate my sample while I polish, just a little bit, but the last few seconds, keep it in one direction, keep it in one orientation. Again, so you can see the scratches are in one direction. Now, we're not there yet. The sample is clearly not there. You can see that it's slightly polished here, but not here. So we're going to need a significant more time, a significant amount of time, maybe 5 or 6 minutes anyway, to achieve a uniform surface. But we'll get there. Just keep going until you see a uniform surface. Now, once you complete that step, turn off the platen, turn off the water, and remove the guard and the ring, and go to either 1500 or 2000 paper. Again, we're increasing grade paper because we're getting finer and finer throughout this process. Repeat the steps. Replace the paper. The TA will provide the paper. I'll leave it right here to dry. When you're finished, replace the ring, the guard, and the lid. Wipe up your water. Make sure that all the faucets are in the sink rather than on top of the countertop. Make sure that you turn off the water in the platen. Wipe everything up. Good to go. After that, you'll come over here to the fine polish. Now, you'll notice there are 4 machines. These are Lico SS200 fine polishing benches. This is very important. The first 2 on the left are used only for one type of suspension, which is the 0.3 micron suspension. The 2 on the right are ultra-fine polishers, and they are only to be used with the 0.05 micron suspension. You'll notice that the various suspensions are labeled 0.05, 0.05, 0.3. Only use 0.3 suspension on these two machines. Only use the 0.05 suspension on these two. Likewise, the polishing cloths that you use, which are generally up here, your TA will provide, keep them for use only with the machine they're intended for. The general rule is use the polishing pad that's above the machine you're using. So, again, make sure that on the machines that are labeled, you're using the pad and the fluid that goes with that machine, and don't cross-contaminate. Remove the ring, place the pad, replace the ring. Okay? Here's your fluid. Turn on the machine here. Put your water source maybe around the middle of your platen. Turn on the water here. You don't need a lot of water, just enough to keep it nice and wet while you're polishing. Turn on the platen. Okay, if it doesn't work, it may be that the emergency stop is pressed, and it was. So we're getting all the curveballs today. So if it won't come on, turn the emergency stop to the right, and it should pop out. The stop light will come on. Now you can turn on the platen, and you'll see it begin to rotate. You can adjust the speed. I would say, 180, 200, in that range is probably about right. Your water source doesn't need to be very high flow. You can turn it on and off here. I would say something like that. Actually, I'm sorry. Actually, you want it more or less dripping. And the reason is because you don't want the water to wash away the fluid. So we don't need that right now. That's confusing. This is the sample that we had a few minutes ago. You want to add a little bit of fluid, not a lot, just a few drops. Try to use one that's got some fluid in it. It's clogged. Anyway, you just need a few drops of fluid. You get the idea. You may have to, if it's clogged, you may have to, I'll show you what to do. Get one of these swabs, which are generally located up here, and use the back end to try to unclog your sample. If you can. But anyway, you shouldn't have that problem. So anyway, a little bit of the, this is alumina suspension, not aluminum, but put a few drops of that, polish your sample. You are welcome to, try different techniques to get a good polish. I like to do it this way, and it seems to result in a pretty good finish. What you're doing now, we're no longer talking about grit size, like 180 or 120, 320, 600, 1000. We're just talking about particle size. So you want to complete the 0.3 micron polishing step. When you're finished, turn off the platen, turn off the water, remove the ring, remove the pad, replace the pad up here, put the ring back on. Very important at this point, turn on the water, rinse off the platen and the bowl to leave a nice machine or nice condition for the next person. We try to keep alumina from building up in the bowl or on the platen, so please be kind to your fellow students and and university employees by cleaning this when you're done. So when you're done, turn off the water, turn off the main power switch, wipe everything up, no standing water, and you're good to go. Now, at this point, I want you to do the same thing on the fine polish, the ultra fine polish, to get the best possible surface for microscopy work. Very same deal. Use the right particle size lubricant that matches your machine. Use the right pad on these two machines. Repeat the process as before. Other than that, I think everything is the same. At this point, you should have a sample that pretty much looks like a mirror. You should not be able to see any scratches. It should be a very, very nice, shiny, reflective surface. Now, the next thing you're going to do is don your safety equipment, face shield, lab apron or lab coat, gloves. We will have gloves, okay, but you will need gloves. Actually, I'm looking for the nitrile disposable gloves. Once you have all your safety equipment in place, come over here to the fume hood. Open the fume hood. I like to do it about like this, and I'll tell you why. Turn on the light. I hope you can hear me okay. I'll try to talk loudly. I like to go ahead and turn on the water right here, the bottom valve. It's very stiff, but turn on the water just to get a nice little flow going, because you're going to want to rinse your sample. Your TA will provide the acid that is used for etching. And to be clear, this is acid. It's called nitol. It's about 1 or 2% nitric acid in methanol. And the nitol is short for nitric acid and methanol. It is not, as acids go, it is not a very dangerous one, but you still don't want to get it on your skin or in your eyes, so God forbid that. So be careful. Wear your face shield, wear your gloves, wear your apron or lab coat. Now, at this point, take the sample that you just polished. Now, I'm not actually going to use the acid, so I'm not wearing safety equipment, okay? I'm just demonstrating what you're going to do. When you do this, you will be wearing the safety equipment. So, your acid will be located here. Simply dip the swab in the acid, come over here to the sink, and gently swab your sample. Again, you will dip your swab in the acid, gently swab the surface of your sample. Don't press hard, just gently swab multiple times. Keep going back and forth. The reason is, if you put the acid on there and let it sit, it will oxidize and build up what we call smut. You don't want to do that. So you want to keep a gentle wiping action as the etchant is working. The reason we're doing this is that the etchant will preferentially etch the microstructure, grain boundaries, and other features of the microstructure so that you can see them under a microscope. Without the etchant, all you would see is shiny metal. But what you want to see in this lab is microstructure. That's what we're doing. I'll show you how we see the microstructure in just a minute. But just so you understand the purpose of this, the etchant is used to preferentially, the acid is used to preferentially etch the sample to achieve microstructure that you can see under a microscope. So again, dip your swab in the sample, gently go back and forth multiple times, probably 20 to 40 seconds. Start at 20. While you're swabbing, very quickly rinse your sample. Rinse your sample very thoroughly. That will arrest the etching action and clean the sample so that you can handle it with your bare hands. So etch it with acid, throw your swab away. We have plenty more. Rinse the sample, And then over here, at this point, you're still wearing your face shield, apron, and gloves, even though I'm not wearing them because I didn't actually touch the acid. You will be using acid, so you wear the safety equipment. Resist the temptation to touch your glasses or anything else. You can turn on the hand dryer, dry off your sample to remove the water. You have already rinsed your sample very, very carefully, so there's no acid here. This is just water. So we're drying your sample with water. Do not dry it with acid on it. That's not what we're doing. Rinse it very carefully first. Dry it with a hand dryer. And when you're done, you're ready for microscopy. Once you're finished with your etching process, turn off the water, turn off the light, replace the wipe everything up with gloves on, of course. Okay, do all this with your safety equipment on. Replace the panels according to the diagram shown here. This is important because it keeps the airflow regulated. This is a fume hood. This is the sash. These are the windows which access the fume hood through the sash. And if these are left open or in the wrong position, the airflow is improper and it can mess things up. So leave your work area clean and ready for the next operator. This is the Zeiss Axiovert 10 inverted compound microscope. It has a dust cover on it, or it's supposed to. Remove the dust cover. These are the eyepieces. These are the objective lenses underneath. They are mounted on what's called a nose piece that you can turn to achieve different magnification. And you'll see that on the objective lenses, a certain magnification is printed, and you will need to know that for your report, okay? This is the camera. The camera is connected with a wireless connection to the computer. Over here is the light source. The light source is located right here. This is the control. Turn it on, and you will see light in the light path. And you can place your sample upside down, being careful not to scratch it at all. Place it upside down on the hole in the stage under which the objective lens is located. Just like that. Now, you can position your sample with this compound actuator. You'll notice that there are two concentric knobs here which are serrated. This one goes front and back. You can see as I turn it, the stage is moving forward and backward. The lower one goes side to side, left and right. So that's how you move your sample. You don't need to move your sample which can scratch it. You move your sample around with these controls. When you get, and you can see through the eyepiece what your sample looks like, just like any other microscope. If you'll notice on the right-hand side near the eyepieces is a plunger. The plunger changes the light path from the eyepiece to the camera. If you don't see through your eyepieces, pull the plunger out so that you can see through the eyepieces. When you see an image you like, push the plunger in and then come over here to the computer. The login information is printed on the card on the side of this computer box. And so what you want to do is Control-Alt-Delete, log in, and the login is, let me do that real quick, it's printed here so I don't need to tell you that right now. Bear with me. And the password is also printed there. Be careful that you notice the difference between letters and numbers. There are letters and numbers which are changed out periodically. Press OK, and then wait. a few seconds while the desktop becomes available. Now the software we're going to use is called AmScope. AmScope is the brand of the camera. So double click on the icon for AmScope and wait a few seconds for the camera to open up. And the desktop should look like this. Now you'll notice, this is very important, it says no device. That means that the software is not connected to the camera. Well, again, I think I mentioned that the camera is connected wirelessly. So come down here to the internet connections, which looks like a computer monitor with a cable in front of it. Click on that. And of course, wait a few seconds. And you should see some options. One of the options you're going to see, hopefully, is WF200 5873E9. And that information should match the information on the label on the side of the camera. Okay? Now, there are multiple wireless cameras in this room, so make sure you choose the one that matches the label information. That's that one right there. Click on it, connect. Now, the password on that, if it asks for one, is ultra secret. It's 1 2 3 4 5 6 7 8. So if you need that, it's also printed there. But it should be good to go here in a second. Once you see the camera on this side, over here under the menu on the left-hand side, you can choose it, and hopefully you'll see an image. If you don't see an image, and pull the plunger out, as I mentioned earlier, and you should see something bright, okay? Now, this is out of focus. This is the focus. There's one of these on each side of the machine. They're diametrically or on opposite sides. The outside ring is the rough focus. The inside ring is the fine focus. So I'm using the right-hand side to focus until I get a clear image, and then I can use the fine focus. Now, this is too washed out. You can make adjustments to your image over here on the same menu we used before. You have exposure, exposure time and gain, white balance, green, blue, hue, saturation, brightness, contrast. These are just slide meters. I would probably start with a white balance and then maybe reduce the exposure, brightness, contrast, until you get a nice looking image. Okay, that may take you a few minutes, but these are the controls. Don't panic if you get things out of control, because you can always hit the defaults to take it back to the factory setting. That's pretty much all you need to know there. When you've got an image that you like and it's in focus, and just so you're clear, this is a horrible image, okay? This is not the kind of image that you're going to have. This is just the dummy sample that I was using. It has a lot of scratches. There's no microstructure. I'm just illustrating the process. But when you do have an image that you like, and by the way, it should look like some of these, okay? And it should look like some of the images in your handout. But once you have your image, snap, and then the other thing you're gonna want to make sure you have is a scale bar. Now, for all of your labs going forward, for the rest of your life, okay, when you have a microscope image, you want to have a scale bar. The scale bar has got to match the physical reality of your image. So what you want to do is, and by the way, without a scale bar, the viewer has no idea what the relative size of the features in your image are. So a scale bar is very, very important for this class and other classes, and for your professional life. So choose scale bar, and micrometer. So for the scale bar, what you have to do is come over here to Options, Magnification, choose Options, excuse me, sorry, Magnification, and then choose the magnification that matches the objective lens underneath the stage. It will probably either be 20x or 100x. Ask your TA if you have any questions. Let's say it's 20x. Choose OK. Then come over here to Measurements, Scale Bar, and then enter a value for the length of the scale bar you want. Let's say 50 microns. And there it is. So from here going forward, your scale bars should be located. Let's see what's going on here. Okay, I'm sorry. Can we just delete that last video and start over? All right, go ahead. So again, go to Magnification, choose the one that matches your objective lens. Okay, Measurements, Scale Bar, choose a value. Just choose something standard like 50, 75, 100. Makes sense. Now, you on your image, relative to your image, the length of this line represents 50 microns. So now you can move it to the lower right of your sample, and if it doesn't move, come over here and select the track tool or the object select tool, and then you should be able to move it. So once it's there, then you want to go up here to Layer, Merge to Image. Okay, now what we just did was we took this previously mobile scale bar and we locked it down on the image. It's now part of the image. It can't be moved anymore, okay? Then you want to save your image, File, Save As. Your TA will tell you where to put the image, but choose a file name. Make sure that it's JPEG or TIFF according to your TA's instructions. But let's be consistent. Click Save, and it'll save. All right, that's pretty much it. You're going to have multiple images. Again, what you're trying to achieve is microstructure that looks like that which is published on the poster and in your lab handout. Hopefully your microstructure will not look like this, because this is garbage, okay? This is just for demonstration purposes. So make sure you save your images. Make sure that in all your images, your scale bars are the same color. Within each magnification, they need to be the same value, and they need to be in the same position. It just makes for a nicer looking report. And make sure you lock this. Make sure you using the layer merge feature that you lock the scale bar down to your image. Otherwise, when you save your image, the scale bar won't be there, and that's a problem. So at this point, you'll have multiple images to take, but just for future reference, you want to close the software, log out. Very important, turn off the light source. Okay, till you hear it click. Turn to the left till you hear it click. Replace the dust cover over the camera and the eyepiece, and that's it.